Alright, today we're going to be looking at 6.3, Poisson probability distribution. We have three objectives. One, determine if the experiment is a Poisson process. Two, we're going to compute the probabilities of a Poisson process. And three, find the mean and standard deviation of a Poisson random variable. Alright, on the first page, they give you a little bit of background. It tells you that this is a discrete model. It's named after Simon Dennis Poisson. That's a person's name, so it's not Poison, it's Poisson. They give you a little illustration showing you what a Poisson process is, so definitely good reads. The definition I'll read out, which kind of lets you know you're dealing with a Poisson distribution. So it says a random variable x, which is the number of successes in a fixed interval. It will follow a Poisson process provided the following conditions are met. So if you have two or more successes in any small subinterval, probability is 0. The probability of success in the same interval for any two intervals of equal length. So they're saying the probability is the same for the number of successes or the success in any intervals of equal length. And then 3, the number of success in any interval is independent of the number of success in any other interval, provided the intervals are not overlapping. Okay, so then they kind of go into a little more detail in the example they're giving you, telling you about cars that show up in the drive-through at a specific time, give you an average rate, and it kind of goes through why it is a Poisson process. Here we actually get the formula, mathematical formula for a Poisson distribution. So again, it's telling you x is the number of successes in any interval of a fixed length t, and then the probability of obtaining x successes in this interval is given by this distribution. This Greek letter is lambda, looks like an upside down y, lambda times t raised to the x power. Lambda and t are your mean. Poisson really only needs one parameter. This textbook shows you lambda, which is the average times the number of time intervals, which will give you your mean, and then raised to the power e to the negative lambda t, all divided by x factorial. And then here it spells it out. This Greek letter lambda represents the average number of occurrences in some interval of length 1, and e is exponential, given by 2.71 around it. So they give you some examples, which I'm not going to go over. I'll just kind of show you as we do problems in my math lab. Let me see if there was some other important. Okay, so here we talk about the mean and standard deviation. So it says a random variable x follows a Poisson process with a parameter lambda has mean or expected value, and the standard deviation given by these formulas. So mu is what we've learned to be the mean. So mu sub x is just saying the mean of the random variable x is equal to lambda times t. So this is the parameter I was mentioning earlier, the one parameter we really need. Find the mean. And so it's kind of confusing because you get two different means. Lambda is called the mean or expected value, and then mu is also the mean. So we'll kind of differentiate that when we start working some of the problems. They also kind of mention that right here. Since the expected value of a random variable is the mean of the random variable, it's reasonable that mu x and lambda t for the interval t is the same. And then once you want to find the standard deviation, you just take the square root of the mean, and that gives you the standard deviation. So a little bit different computation here. This one says if x is the number of successes in an interval of fixed length, x follows a Poisson process with mean mu. The probability distribution function for x is given here. So this is a simplified version. This is the one I'm more used to when you're trying to find the actual formula for the Poisson process. It is the mean raised to the power x over x factorial, and then e raised to the power of that mean, negative power of that mean. So we'll get an average per interval. We'll multiply the number of intervals times that average, and that will give us the average for that problem. And then here are just some more examples and approach and solutions, and then interpretation. So when we do this, we're going to be using either calculator or StatCrunch, probably StatCrunch, and I will show you how to compute the probability. You won't have to use this formula, but it's good to know what it looks like. And I think that will cover all the objectives. This just kind of goes over how to enter it into your calculator. And so with that, we're going to jump into my math lab and start working a few problems.